I think the biggest method that I used for like the theoretical AI trying to get to AGI was honestly analyzing my own behaviors or other people's behaviors. And if someone would say something interesting that was like, that's kind of a weird way to phrase it. Why'd you phrase it like that? Or if I would notice a thought process that was triggered by something in my environment, I would like think about the scenarios a lot and then try to reason about how that was structured in my brain. Yeah, that would lead to some interesting thoughts, at least. That would try to make me think of new models.
The Research Labs podcast by Sunday Pajamas.
Nick, I would say, first of all, thank you for your time.
Yeah, thank you for having me here today.
How about you share a tiny bit about how you got introduced to computers? Was it in school or was it in college? How was it?
I guess definitely when I was very little, I started playing computer games like RuneScape online, and that was my first introduction to computers. And even in middle school, we did like some computer programming on Sketch, it was called, or sorry, Scratch. So was exposed to a little bit of programming then, and we even had this like 3D modeling, essentially metaverse, where we were building in this virtual world. And that got me really excited about like architecture, but never really touched computers too much after that, especially computer programming until college. Yeah, going into college, I really wanted to be an entrepreneur and start a company of my own one day. So I was thinking about a lot of different majors, and business and engineering were kind of at the top of my list because of wanting to be an entrepreneur in the future. And business, I was like, oh, I can just learn that any day or like anytime in the future, which is definitely not as true as I once thought. um, but yeah, I decided to go for engineering. And then with engineering, I thought computer science made the most sense. Given that I wanted to start a company, I could build a mobile app and a website. So yeah, I got into computer science through my selection of major choices, I suppose. And yeah, then um, was excited by computer science and like enjoyed the classes. But I got into my first internship doing software development for a tax accounting software, and it was pretty boring. I was just like debugging other people's code and not really like developing anything interesting. So that was after my sophomore year of college, and was like, all right, I'm gonna need a career change because like or a major change because I cannot do that for the rest of my life.
Yeah,
But luckily learned about machine learning and AI. And for me, that was super exciting because I was really interested in psychology, but never thought I could really make a career out of that. But with machine learning, it was enticing building a computer as smart as a human. And then in order to do that, you need to understand the human brain. Or, well, that's one possible route to get there. But yeah,
yeah.
so I got really excited by machine learning from that and started to pursue more activities in that realm of things.
You mentioned learning about the human brain to also figure out how to train a computer. Could you share a little more about what working in machine learning or AI looks like?
It can look many different ways for sure. I think kind of the two main paths are development and research. So, development is much more applied, where you might be working at a startup and they want to train a recommendation algorithm for their company to recommend new products to a user. And with that, there's already a lot of models and that you can use. And then it's a matter of implementing them. So you're not necessarily doing anything novel, but you need to be aware of what different models you could use and what data you need to collect from the company in order to train the model. So yeah, you kind of just need to understand some basics about training and testing models in order to do the applied AI. And from that, there's a lot of different algorithms online that you can take out of the box where you don't even have to code them. You can just essentially call an API that says train and run. So, yeah, kind of part of the challenge there doing the applied AI is getting it to work efficiently and getting it to work in production. And so that's making it work fast. And then also being able to push it to a system without any bugs. So I think that's one area. And to me, that wasn't as exciting because for me, creating artificial general intelligence, which is a computer as smart as a human, is the most exciting thing about AI. So yeah, luckily I was able to get a job doing AI research right after college. And with that, it was initially applying AI to new domains that we as IBM hadn't been doing previously. So I was in the storage systems team, and with that, we were looking at how can we apply AI to helping storage administrators back up their data more efficiently, delete their data more efficiently so they can save storage, and then also to protect their data. So if they get a ransomware attack, can we detect the ransomware attack and essentially back up their data before that happens? In that scenario, we're looking at what models, like what data can we collect in order to do these different detection algorithms. And then from that, what kind of algorithms would we run on this data? Do we need to develop new algorithms to do this? And for me, mostly I was working on patents. So just like coming up with new ideas of how we could implement this and kind of designing a system around it. And that was super interesting because like I didn't have to do a ton of development work, which isn't always the most fun when you're dealing with bugs of programs. So that I like the high level thinking about that. And yeah, so that was kind of still applied, but a little bit research based because like what exactly what we had been doing hadn't been done before. And yeah, also then got into some more theoretical AI teams while I was at IBM because that was kind of my goal to build AGI. So wanted to work towards that. And there I was working on a team where we are thinking about how to integrate Daniel Kahneman's the theory of how the mind works into AI. So if you're familiar with him, his book is called Thinking Fast and Slow. So he theorizes that there's a slow part of the brain and a fast part of the brain. The slow part is like your conscious thought, your logical reasoning, you deliberately deciding, what do I want to eat today? Or like something along those lines. And then your fast thinking is kind of your unconscious that just has a gut reaction while you're driving. You're not even thinking about it, you're just doing it. So, what we were essentially theorizing is that in AI, we should have a fast and slow thinking as well. And then a lot of our discussions was, okay, what does that actually look like? What models should we develop for this? How do you switch between system one and system two thinking? When is one activated versus the other? So, yeah, we had a lot of questions about that. We're designing high level systems to essentially, tr- um, one, have a fast thinking brain, which is essentially deep learning, where it kind of just goes through the neural network. The data goes through a neural network and you get an output. And it's not very explainable. And then we had a system two version, which was a symbolic AI, which does logical reasoning with symbols, and you can get some explanation from that. So, yeah, that was kind of the last team that I was working on. And yeah, that's kind of the world of AI, I suppose.
So you mentioned that you were designing a lot of AI systems. Could you maybe paint a picture, the process or like the thinking behind designing such a system? What I mean by that, right, is that when you start designing a system around a problem, what are like the frameworks or parameters that you kind of keep in mind when designing it?
Yeah, definitely. I think starting with a goal is very important. So, what do you want your model to achieve is kind of like step one. Once you establish that, then the next part is what data do I have available for me to achieve that goal? Um, and then with the data, you really want to look at like your input data and your output data. So, what data is essentially predictive of your output is the input data. Um, and then the variable you're trying to predict is the output data, and that's tied to your goal that you're trying to achieve. So from there, and this is more in the applied case where you're designing a system for a specific problem. Um, okay, I'll get into the more theoretical aspect in a second. But yeah, so you start with your goal, then your data, separate that between input and output data. And then typically there are like these decision trees you can go through where it essentially asks you a few problems or questions about the problem that you're trying to solve. So like, do you have continuous data or discrete data? Um, are you trying to predict multiple things or just a binary yes or no? And you can kind of go through these decision trees and they will end in an algorithm that you could choose based on your scenario that you're going through. Um, so that's, I guess, one way. And then, yeah, once you actually decide on the algorithm to use, um, then implementing it is pretty straightforward. There's not like really much of a process there. But yeah, making sure you can test it and debug it is definitely a challenge that requires a lot of thought.
You were also doing a lot of high level thinking and coming up with new ideas to do things that were never done before, for example, right? So, is it fair to say you were doing something that can be termed as hypothesis generation?
Yeah, yeah, definitely.
Like you come up with an hypothesis and then try to figure out if it's true or not, or if it will work or not.
Yeah, definitely. And that was more of a framework that I did want to get into, but I guess I wasn't trained classically in research, so my thought processes wasn't just like, what's my hypothesis that I'm trying to figure out? I think with like creating artificial general intelligence, probably did have a lot of hypotheses that just weren't explicitly stated as hypotheses. Yeah, I was super excited about like, okay, what are concepts in the brain? Because it feels like we have an idea of what a water bottle is or what a picture is, um, and then we assign attributes to it. And for me, this was a super interesting thing that I feel like deep learning doesn't do currently. This has symbolic representation for objects in our environment. And so, yeah, was proposing a lot of questions around that and essentially thinking a lot about different models and how we could create models that actually have a representation of concepts that form a little bit more naturally. So,
What do you mean by representation of concepts?
so like I have this water bottle. um, and I know that I can drink from it. I know that it can be filled with something. I know that it's clear, has a black top. Um, and so all these things like a black top can be filled up, can be drank, are concepts. And all these concepts are tied to the concept of a water bottle.
Got it.
A concept essentially is anything in the environment and anything that you can assign meaning to. Um, and now that I have an idea of what one water bottle looks like, I can see a new water bottle and know how to use it.
Yeah,
Yeah. And similarly, like with the color black, I can see the color black here and then see it in other places and have associations with that concept and can, yeah, act in my environment accordingly based on how I had seen it in the past.
So there are models that are already out there that can understand these things.
Understanding is a tough word. It
Okay.
has to be
Sorry.
defined too, but no, I mean,
Okay.
you're good.
Yeah, yeah.
But it's like I was actually working on a project that was essentially how do we measure intelligence in AI? Um, because we want to measure essentially how smart AI is compared to humans. And right now, we just kind of have a lot of benchmarks. Like, does it do well on the specific task? What's the accuracy that it achieves on that task? Yeah, people at IBM were like, we need a better test that measures general intelligence so that we can know which models are most likely to lead to general intelligence. And yeah, so part of that is defining what intelligence means so that you can get to testing intelligence. And then part of defining intelligence is like how well does something understand other concepts. So yeah, for understanding, it's tough definition, but the way that I was thinking about it in the past and kind of rejogging my own memory now, um, was essentially the complexity. So, like a water bottle is a pretty simple concept. There's not too many features associated with it. It can only do a few functions. Um, something like flying to Mars is a pretty complex concept. It requires a lot of understanding of rocket propulsion, physics, and yeah, knowing about Earth and space and how gravity works.
Correct. Yeah.
Okay, so that's like simple concepts versus complex concepts. And then how to test if you understand either of those concepts could be done through more specific benchmarks like we currently have, like object detection or being able to predict what's going to happen next in a video frame. So those are different skills that AI can possess. So my thought for how to test if AI understands a concept was essentially to say how many different skills can the AI accurately perform on a concept. So, can it detect the water bottle and can it detect flying to Mars? Can it predict that that's going to happen if like there's a scene right before it that's about to happen? And like, could it decompose it into all its subcomponents? And there's like there's many skills that could be defined for um, AI to perform on a concept. So my thinking was that for determining the understanding that AI has in a concept is how many skills can it perform on that concept.
Yeah.
And then intelligence kind of comes in here where how complex are the concepts that AI has performed the skills on. So if it can understand more complex concepts, then it's probably more intelligent.
One thing I'm thinking is if you want to figure out if an AI is more intelligent than humans or human intelligence, right? Then we also need to figure out how to measure human intelligence.
Yeah.
The idea about having a general intelligence from a machine perspective is that it can do what we can do, right?
Hmm.
And to figure out that general intelligence, artificial general intelligence, is better than ours, how do we measure ours first?
Yeah, that's definitely a big topic as well. Um, it's like IQ tests have been done to try to measure people's, yeah, kind of general intelligence. And kind of what you're describing, like tasks that we can do that AI should be able to do if they're as smart as us, that was kind of like the first, or well, there's it's called, I think, the Wozniak test. Um, and it's essentially if AI can go make a cup of coffee, like just walk into any room and make a cup of coffee that has a coffee machine, um, then it's as smart as humans because that takes so much coordination and knowledge of what to do. Um, and then there's also like a Turing test. If you can talk to, if a human talks to AI like through a black screen and can not distinguish if it's AI or human, then we've reached artificial general intelligence. Um, and in those two scenarios, you don't really have like, oh, we're 50% there, we're 75% there. You just kind of have like, we're there or we're not there. Yeah, that's debatable. The Turing test, you could potentially say like, oh, well, they fooled you for 5 minutes, so that's certain length of time. But yeah, the intelligence test, there's someone named Francis Cholet, and his model is for testing intelligence is like pattern recognition, essentially. Um, and I think that's more akin to the intelligent, like the IQ test, where you're given, yeah, in his scenario, it's like you're given shapes and like a before and after for one example, and then you'd see a new shape, and now you see the before, and you have to determine what the after is. Um, and yeah, I think that gets us part of the way. I think it like shows some underlying knowledge or ways of like processing data that is interesting and is useful for pattern recognition. But making the step from being able to detect shapes to being able to detect cancer and like the intricacies of the human body and just visual components and audio components, that feels like not a straightforward transition from just like shapes on a screen to the world essentially. So I think it, like, his model will be beneficial. He has a lot of other interesting aspects about it, so if people are curious, they should definitely go read his paper, which is very long. It's like 30 pages at least.
So, I asked you about hypothesis generation, right? Because I've been, keeping a very close watch on what OpenAI is doing or what DeepMind is doing. And, when you see what their AI is doing, they make it very simple for us to understand from what is written on the website. But that's like the outcome, that's the output.
Mhm.
But how do you know that, or how do you decide as a team or even as a researcher, right, that okay, this is like a good AI problem to solve?
Yeah, I guess kind of in the field of AI, there are a lot of problems that people have been talking about. Um, so explainable AI is kind of a big terminology. Like we want to be able to have models. Like deep learning currently is not explainable, meaning that once we get output, we're not really sure why it outputted that.
Okay, we cannot do like a post-mortem right now.
Yeah. And I mean, there are like implementations now, probably. I've been out for a year and there were implementations a year ago, but they weren't like as readily available or like readily used, maybe because they weren't as great. Um, but yeah, I guess in that scenario, it's like deep learning is this new innovation, and it's useful at certain things, but it still has weaknesses. If we like, if general intelligence is our goal, um, and safe AI systems is our goal. So yeah, I think like whenever there's a new model that comes out, people are pretty aware of the problems with it. Um, and transfer learning is another big problem of like being able to learn on one domain and then take that knowledge and use it in another domain. So I think when people are deciding what problems to solve, they, yeah, have some sense of it just by being in the field for a little while.
Is that also how you came up with ideas in IBM?
That's interesting. Yeah, I feel like I think the biggest method that I used for like the theoretical AI trying to get to AGI was honestly analyzing my own behaviors or other people's behaviors. And if someone would say something interesting that was like, that's a, kind of a weird way to phrase it. Why'd you phrase it like that? Or if I would notice a thought process that was triggered by something in my environment, um, I would like think about the scenarios a lot and then try to reason about how that was structured in my brain. Um, and yeah, that would lead to some interesting thoughts, at least. That would try to make me think of new models and kind of like the high level workings of how, yeah, basically, I was kind of thinking of the brain as like working memory, like long term memory, sensory input, actions, um, and was trying to relate kind of these high level systems to each other and understand how they interact and how one like sensory input can trigger your long term memory and then bring that into working memory and now work with new input data. Um, so I think like the approach when I was analyzing thought was helpful to get a sense of how pieces should connect. Um, like deep learning is essentially just sensory and output. So it's kind of missing the memory aspect and emotions is a big aspect as well. Um, so I think through this high level, like just analyzing my own thought, I was more able to try to connect deep learning with emotion and then working memory and long term memory. Um, and that just gave me like a high level framework of thinking about how new models should be structured. And then I think from like more low level, mm, a more low level approach to tackling the problem, I would read other research papers that are trying to do something innovative with general intelligence. And then at that level, it was thinking more about the neurons and what they are doing in order to form representations of concepts. Um, so yeah, I was kind of like tackling it from both angles and getting towards a model that would connect them all.
And you mentioned that you would look into what thoughts are getting triggered by your environment. So I've been listening to Sam Harris lately and his ideas on thinking, and he has been not debating, but like putting out ideas that, are you really the thinker of your thoughts, or you are just the receiver of your thoughts? Does it make sense to you?
Yeah, I think that gets into like beliefs really. Um,
Mm-hmm.
I don't know if I mean, at the present moment, we don't have the technology to, well, it's a tough question because it's like, who is us and what generates thoughts? Yeah, there's one thought. I have a few thoughts, two thoughts in my mind. One thought is there's like some universal consciousness or a god or whatever you want to call it. Um, and then or maybe even like other world dimensions. There's like maybe some kind of energy in the world, and that is on a plane we can't see or currently can't detect. Um, and that triggers thoughts. Um, so that's one idea. And proving that is probably possible at some point. Hard to do now. So maybe that's true. Um, it does feel like kind of like similar to along the lines of people in the ancient days of like, oh, the gods give the sun each day. Like, how else is that happening? We don't know. um, so I think something that's a little bit more like rooted in our knowledge of the world now is like deep learning. Um, Neurons have a structure and they give meaning. Like once you have an input, it senses that input and produces an output. Um, so I think our brains work like that as well, and we're born with some innate detections of the world that trigger your emotions, which give us some meaning or like cause to action. So I think really our environment triggers thoughts, and our thoughts can also trigger thoughts.
Yeah, yeah, yeah.
So yeah, I guess in my perspective, like our environment and ourselves both trigger thoughts. And so I guess from Sam Harris's definition, it's like when our thoughts are triggering thoughts, that feels more like ourselves thinking for ourselves. When our environment triggers our thoughts, that's more just like an innate reaction. Um, if there's like an energy triggering our thoughts, maybe, but it feels less likely.
Yeah, in the example he was giving, right, is that close your eyes and think of the best 5 movies you have watched in your life. Okay. And then he goes on to, ask another question is, okay, so 5 movies came to your mind. Did you decide that these are the 5 movies I want to think about? Or these are the only 5 movies you can actually remember right now? Because chances are that you have watched hundreds of movies in your life, but only 5 of them kind of showed up. And if I showed you those other 100 that you're not able to remember right now, you would want to change your mind. Oh, wait a minute. No, 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 no. Maybe the movie that did not even come to my mind is a better movie than the 5 I chose. So, with that, he kind of goes on to, debate the idea that is it like a memory thing, or are we even deciding what we want to think? And if we are not deciding, then what how is it that we call it free will? If you're not deciding what to think, then how is it free will?
For myself, when I was thinking about it, I like went back to very memorable movies. Like Interstellar
Mhm.
was one that came to mind.
Yeah, yeah, yeah,
Jumanji was one, which is kind of interesting. Haven't
yeah,
thought about that in a while.
yeah,
And I was definitely trying to do a lot of conscious thought of like, what movies have I watched, and trying to like just visualize something, and then maybe one would stick out.
yeah,
Um, so it definitely felt very deliberate. Like 5 ideas just didn't come to mind immediately for myself. So I think, yeah, that example is, I feel like maybe tough to determine if we have free will. But in that example with free will, I would say that the initial things that came to mind weren't of our own conscious thought, but they were formed from our own experience. So I guess it's almost like our past selves who are the ones thinking for us in that scenario. So is that our current self? Is that our free will to determine those ideas? Not really, in the sense that we think of free will. Um, but I think once those ideas come to mind, now we have the ability to determine if those are the movies that we want to pick. If he gives you like 10 seconds to make that decision, then he's taking away your free will. But if you have like a day to debate about it, then I think you do have the free will to determine what your favorite movies are.
When you are studying the human mind to kind of design computer systems, do you also think that, while designing systems, you also learn a little bit more about how the human mind works? Like the reverse is also true.
Yeah, I like that kind of top-down approach I was talking about, whereas in analyzing my own thoughts and other people's thoughts. I think I definitely got a sense of, yeah, how people operate and how emotions come into play and how we relate concepts to each other. Um, and then also just getting into the field, I was thinking, oh, it's probably a good idea to study the brain. And so, like, for that in college, I took neuroscience classes and cognitive science classes, and there we like formally studied how the human brain works. So, yeah, I think just going into the space requires some amount of knowledge that required me to study up on. But then, yeah, while actually performing it, I definitely thought a lot about how the human brain works. And then, yeah, when I was encountering problems or like questions, like how many things can we hold in working memory at a time? Like how many should AI hold in its working memory at a time? Then I would do more research into how the human brain does something and kind of take that as a baseline and think like, is there significance to only having like 7 things in the working memory? Is that important to limit the number, or should we just have infinite number because it's a machine and it can hold infinite? Well, yeah.
Like the question being, why should the machine have
Mm,
the limitations of the
yeah.
human brain?
In some scenarios, I think it could be useful to have limitations. Um, like in that working memory example, if you can hold a million things in working memory, then you might start relating things that aren't really related, depending on how your structure is created.
What do you think about what Neuralink is trying to do?
Brain computer interfaces. Super excited about that. um, so yeah, I remember in college I saw not Neuralink doing something, but it was research that was done, and I think it was an EEG they attached to someone's head. So it detects brain signals, electrical signals of the brain, without having to be invasive. Um, and they were looking mostly at like the visual cortex, which is in the back of the brain, looking at the signals from there. And they would have someone sit with the EEG on, and then they would show them numbers, like 1 through 10. And then each time they'd show them a number, they would see how the visual cortex lights up from the EEG readings. And then they would have this data set now of what the EEG looks like, and then what number is associated with that. And then they put this data through a model that takes in visual input, or yeah, whatever EEG input, I guess, and then outputs visual input. Um, and they
So what number the brain is watching?
and the like thing that they were predicting was the number that they showed the individual. So they used that to train the model. And yeah, they were able to in real time essentially monitor someone's brain, show them an image, and then they would have the model predict the number that they're thinking. So that's essentially what Neuralink is doing, um, where they, I guess, like, I don't keep up too much with them, honestly, but I remember seeing that they do the eye tracking for the mouse. Um, And so I imagine it's similar. They were taking a lot of data sets of people looking at different corners of the screen, or probably like a specific dot on the screen, and then recording. Probably, I think for them, they were probably just recording smaller neurons for like that specific task. Yeah, I don't know exactly if it was like an invasive model, but I think that's kind of their thing, is to do more invasive models and have it be very high fidelity. So yeah, I imagine it was collecting data points like that and then training a model from those data points and then now using it in real time.
Essentially, it also sh- kind of shows that, if a human brain is doing, like looking at the number three, for example, then all the human brains will get active at the same places. There will be similar activity in all the human brains, regardless of where the human brain is, whether it's in a different part of the world, does not matter.
Yeah, that's a good question. Um, from my limited knowledge of that one experiment, my assumption is that it was applicable across many individuals. I'm not sure if they did like a slight retraining for each new person, but yeah, definitely human brains are similar.
I'm actually, trying to think from what you mentioned about meaning, that the bottle has a meaning in our brain. That's why we know it's a bottle. So, what if you show someone something that his or her brain does not understand? Then will the brain have a similar activity, or it will be slightly different?
Definitely different. Because I think your brain goes into new processing power or mode, I guess is a way to say that. Um, and I think that like babies, when they're surprised, um, they stare longer. So yeah, I think we go into like a more curious mode of thinking when we don't know something, and we tend to give it our attention longer until we can make sense of it. Um, and so the act of making sense, I think, is essentially relating that thing that we don't know to our world knowledge that we do already have. And yeah, I think once we can get that, or once we determine that this thing isn't interesting, then we just walk away from it. Um, and I think that's something that's different about every human, is like how long will they spend trying to figure out the thing, and like how long will it captivate their attention. Even my niece and nephew, who are like under 2 years old, I see my niece is like she'll stare at the thing longer and like try to understand it, and the nephew might not even notice the thing.
Yeah, yeah, yeah. Do you feel even like things like motivation and interest play a role?
Definitely, yeah. Um, yeah. I'm like thinking, and probably more like the context, but the context is a very vague term. Like if you're at a party and you see something weird, like I guess your opportunity cost is a way to put it. Are other things in your environment capturing your attention more so than that one thing? So yeah, I guess your opportunity cost, your motivation for learning about something, like is it related to a topic you care about? And I think there is like some innate level of curiosity that people have for new things. Um, there's probably other factors as well that go into how long someone will spend trying to figure something out.
When we also, for example, talk about general intelligence, right? Do you guys also think about things like motivation when thinking about artificial general intelligence? Like what should motivate the AI to do something or not?
Yes.
Because it's general, so it will not have a very specific goal. So there has to be some intent in the system that will kind of compel it to do something.
One thought initially was like to make humans happy, essentially, to be the goal. Um, like satisfy our own curiosities. Another thought was to understand things. um, maybe when I was thinking that route, I was just kind of breaking it down like I had previously defined understanding. And I think something about new knowledge was interesting to me. Um, Because like if we want AI to cure cancer, it has to come up with new knowledge. Um, so a motivation for AI should be to find new knowledge or like come up with new ideas. But that could get trickier with generative AI. Like, yeah, AI safety starts to become a concern when it's generating new things because then it could have new ideas um, about potentially harming humans because I had a new idea that humans are terrible.
So when you say that the goal of general AI should be to help us, but what if the general AI just want to be by itself and not serve as a tool for us? Is that a possibility?
Yeah, honestly, once general intelligence exists, I feel like anything's a possibility. Yeah. So I could definitely see it wanting to sit alone.
And I think you also mentioned that you actually considered joining one of the AI firms before trying to build something of your own. So we can definitely discuss that. So since you did not join them and you're trying to do something of your own, let's talk about what you're trying to build right now.
So, yeah, basically trying to build a new way to do college. So, in the US, it's very expensive, and the quality of education could be a lot better. Um, right now, we have professors who are world-class researchers, not world-class teachers, who are teaching everybody. I think that's like an inefficient use of time, and especially in an age where there's so many content creators online who are really great at teaching. Like Khan Academy, for instance, he's starting his own school, which is interesting. Um, so yeah, we think we can do education better. But we do think college is a great experience for individuals. They're moving away from home generally, trying to live life on their own, and they're surrounded by a bunch of smart, motivated people. So we want to keep that college experience um, because we did enjoy it ourselves, and we think a lot of value can come from it. And yeah, people can like kind of find their passions in life during this time when they're now on their own and being somewhat more independent than they have been in the past, potentially. um, so what we want to do is create a residency where you come live on a college campus and instead of taking classes, live on a college campus where you're with friends and you're still doing the co-living experience, so you still get that social experience. Um, but yeah, instead of doing classes to get a degree, which the degree structure, like being forced on a track, taking required classes is frustrating to me because I think it could be done better. Um, but yeah, so instead of taking classes and like being stuck down one track for 4 years, um, what we require is that you're working on a project, you're working on a skill, and you're involved with one community. Um, and for the project, that could be a startup, it could be a newsletter you want to write, really anything that like serves something more than just yourself, something that helps others or has the intention of helping others in the future. A skill could be really anything. And in that skill development process, like maybe you're trying to learn physics or AI, or you want to learn martial arts or chess or something like that. Um, but in that skill development process, we hope it's tied to your project, but we don't require that. Um, and we create a structure where you're working with peers to learn the topic and you're holding each other accountable, um, and you're giving each other feedback about the best way to learn. Um, so yeah, it's the skill development, and then the community we think is important to join a community, so that you are like you have people in your life. You're engaged in something outside of like the learning work stuff. It's a great ways to meet potential co-founders. Um, and kind of the more novel thing about this is we're the tuition, or there's no tuition, so we're giving all this for free, and in return we get equity in a company if you start a company. And yeah, we're still in the early phases, so the we were previously thinking to take 9% equity in any company that they start during the 4-year program. But the latest thinking is now that we have the option to invest in a student startup if they start a company. Um, that way, yeah, we'll attract a mm, more confident um, student base, because people who are very confident might not want to give up 9% equity right off the bat for this housing. So, yeah, we'll have the right to invest if they do decide to raise money in the future. And yeah, our hope really is that if we have a few successful founders, then that will pay for the whole program for thousands of people. Um, and yeah, we're kind of targeting a founder audience to start, but we definitely think this model can apply to many people. Um, and maybe they're not doing their own projects if they're not like the startup type, but maybe they're doing an apprenticeship for a company, or an internship for a company. And DAOs make that a lot more feasible to do, Web3 companies, because they have open task boards where anyone can start working on tasks for them. And I think that's really powerful because now students don't need a degree to get a decent job. They can just start working, and if they are able to solve the problems, then they can get paid for it. So, yeah, I think DAOs will be really revolutionary in the education space. And I think right now, if we don't implement a program like this, people will just start jumping into remote jobs. Um, People are already doing that. And yeah, the worry there is like a lack of community occurs, and people are just kind of stuck online remotely and not really interacting with people as much as they would like to be. So we really want, in this digital age where remote work is more possible, to have an in real life experience that people can enjoy with each other. Yeah. Yeah, so that's basically the general idea. In addition to kind of housing and the structure for learning, we provide them coaches once a week that they meet with. And the coach kind of is their thinking partner, essentially, who helps them troubleshoot whatever they're going through. We have mentors that they can access who are more domain experts if they need specific advice. We have grants that they can apply for so that if they need extra funding to get their project, then they can get it. And then, like, yeah, bonding experiences as well.
When I went through the pitch deck, for example, right, it was very extensive in the sense I think you guys have really like put in a lot of research and work into coming up with the whole idea. Have you been pitching it to maybe colleges or investors or someone?
Definitely students a lot. Yeah. Um, so when I first started about 4 months ago, I was like, all right, I've got a good idea. Let's start pitching this to some investors. And I think that was too early. There are a lot of specifics of the program that weren't thought through, and hadn't really talked to students yet. So it didn't have like that much external validation. Um, so after that, I was like, okay, yeah, let's start like building this out more. Yeah, let's start building this out more. Let's start talking to more users, and have really been doing that for like the last 3 months. And just brought a co-founder on board and he is super excited about raising money, and he's a finance and legal guy, so that's all up his alley. Um, so yeah, now like we're starting the conversations with investors, and yeah, it's really yeah. Basically, this week is when we're starting, so not too much to report on. But I've gotten some good advisors who, yeah, will introduce us to investors, and I think, yeah, we'll have good success with that.
Yeah, yeah. And what are the kind of questions you guys are trying to answer right now?
I guess like that equity is one aspect where we're just debating. Um, yeah, another thing for me today, my um, work item is figuring out the Twitter strategy, like marketing strategy essentially. Um, and I already have like the general framework for it, but now it's just kind of deciding an order of operations. Um, we'll do a podcast and we'll do a bunch of tweets. Um, so now just getting a little bit more specific about implementing those things.
When you are trying to reinvent the college experience, in my head, right, it's just impossible if you ask me personally. It's I'm only even thinking about it because you are the one doing it. Because if it was up to me, I don't think I can pull it off, frankly,
What do you
right?
think's impossible about it?
Because I think convincing students won't be difficult, but there is, the part where even them, founding companies, even that is very possible. Like the kids these days are really smart, and with the right messaging, it will be, it will be possible to attract the right minds who are committed and motivated and who want to do something. So even that to me is not impossible. But like, why
Why
4 years?
4 years?
You know?
Yeah,
Yeah.
one aspect
Because
is
so also why the question, because like the infrastructure cost of it for 4 years, since you are not charging any kind of fees, it's completely free. So even if you want to, let's say, do a test run, right, you kind of have to do it for 4 years, even just to get started.
yeah, we will be doing 2 years to start for the test run, and there was a debate: should we just do 1 year? Um, um, but I do like the long time horizon, so that people have more time to like actually develop something of value. Um, the thought with 4 years, like definitely an initial reaction. Well, it was originally 5 years, is what I was proposing. Um, just because that feels like enough time for people to like try a startup, fail at the startup, and try a new one. I think it takes like people 2 to 3 years for to reach product market fit. So, and I think it takes like on average, startups fail after 2 years. So at 5 years, they could like maybe have one or two tries at it, maybe even two or three. Um, and yeah, so that's kind of a rationale for the longer time horizon, is just to get more shots at the hoop, essentially. um, and then another aspect is competing with college and offering a similar amount of time for people to develop into adults, I guess is a way to put it. Um, and yeah, with whatever time length we do decide on, um, people will be able to drop out whenever, like maybe they've started something successful and they don't need our help anymore, so they can leave. Yeah, kind of the long term vision of this is like we can support, well, almost like universal basic income for people who want to commit to doing something good for the world and learning. Um, where it's, yeah, if you're willing to go through an education process, We'll pay for you to just live that life. We'll check in with you once a week through your coach. Um, and if you stop like making meaningful progress on the goals that you're setting for yourself, then you're no longer in the program. But if you keep working on that, you can stay as long as you want, and even if that's 10 or 20 years. um, yeah, but then you can also leave whenever. So the time frame right now, we're kind of just setting to have it make sense in people's mind, because generally things are time based. But yeah, in the long run, I definitely think it will be pretty indefinite.
I see. So even for the first 2 years, right? How do you fund the first 2 years? Is it by raising funds?
Yeah. Yeah. So first 2 years, or well, first two cohorts who would each go 2 years. We're raising 7.2 million, and that will be enough to send them through the program. And then after that, we hope to like have a proof of concept essentially, and like the student testimonials. Um, and then we'll go for grant funding because there's a lot of like philanthropists and even government grants for people who want to reinvent higher education. So yeah, we think we can apply for grants after this initial raise, and then hopefully after the grant money runs out, we have some successful entrepreneurs who are coming through the program, and then can sustain ourselves essentially.
Yeah. Yeah, the idea that it kind of depends on the success of the entrepreneurs. Is there like a thought process where you're trying to make sure that more people become successful because they your success is kind of dependent on their success? So 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 are there like any frameworks in the program where you kind of try to optimize for their success?
The coaching is definitely one where they're having someone probe their thought processes so that like we're making sure they're clearly thinking through things. Another aspect is giving them startup ideas, and these ideas come from ourselves, our advisors, our investors, and the thought thinking there is it's a little bit someone with more experience and more domain knowledge on different areas has a better sense of like what is a real problem that people face. College students typically end up working on similar ideas, like let's build a jukebox app for bars and parties, or like a social app so that we can meet more friends in college. Um, so exposing them to new novel ideas is one aspect that they might not have previously did, and then with that, saying like, here are the next 10 steps you should do if you're going to do this idea, so that they like are kind of ensured that they're off to a good start. Um, yeah, I guess those are like, and like mentorship as well, and the skill development is also kind of part of it. But yeah.
So last week I was talking to Emil. He's the designer of the Google Launchpad program. So he never worked for Google, but he kind of started an incubator essentially. And a couple of guys from the South Korean team of Google got interested in what he was doing. They partnered up, and his incubator program kind eventually became the Google Launchpad program. And so he came on the pod, and I was asking him, according to you, right, what makes a great startup program, right? And he pointed out two things. Number one was, how are you selecting the founders to come for the startup program? And I mean, that's very self-explanatory. But then when he talked about the mentors, right, who are going to be a part of the program, he kind of doubled down on the mentors, because he mentioned that most of the startup programs don't work out because their mentors don't work as mentors, but they kind of work as consultants, where instead of probing the founders with questions and making the founders think more about the problems, they kind of just ask them, okay, okay, this is a problem I have seen from my experience, just take a ride and you'll get there. And then, right, and then the founder talks to the next mentor, and the next mentor will be like, oh, from my experience, just take a left here and you'll get there. And the founder is more confused than before. Okay, the first one told me take a
Yeah.
right, the second one is
Yeah,
telling
and
me
the
take a
mentors are
left. What
talking,
am I
so even if
supposed to
it's
do?
like a right, then a
Right.
left, it's like maybe now you just are going down a wobbly path and not aligned on the same goals and values. Yeah, I totally agree. Mentorship is not the way. That's kind of like the way management is traditionally styled in companies. Um, that's actually at IBM how I got familiar with coaching, which is similar to mentorship, but it's more about the probing and asking questions. And at IBM, they had a training available to learn coaching methodology. And in that methodology, it's essentially like we're never giving advice unless they ask for it. Um, or, but yeah, we're always just probing questions and saying, like, why are you doing that? What are your goals? Have you thought of anything else? And trying to get them to think through things more deeply. And then in my class for coaching, they were saying if you do really feel like you should give advice, first ask and be like, is it okay if I give advice? And then put on your mentorship hat and go for it. But yeah, I think the coaching methodology is super powerful because then it relies on the student or the employee to think for themselves and come to their own determination.
This was yeah, this was good. I think we went very deep in AI in the beginning.
Yeah, it's fun to chat about all that and re-jog some memories.
Do you think you will go back to that maybe in the future or no?
Yeah, definitely hope to. Yeah, I'm excited about the models and ideas that I proposed back then. So hopefully we'll work on those one day again.
Well, this was fun. This was fun.
Yeah, I enjoyed it. Thanks for having me on today.